Hey guys, welcome back to another episode of Simuleo. Sorry about that, I started like 2 seconds late. Oh well, doesn't matter that much. Here, let me check my camera, make sure it is at the right location. It looks okay. Yeah, that looks fine. Yeah, sure, why not? I moved it over just a little bit. Yeah, that's pretty good. Yeah. Okay, good. So what we're gonna do today is pretty much exactly what we did yesterday, except with a little bit more, well, work done. One thing I want to point out though is literally, what, 5 minutes before streaming, I found this page. Well, Reddit found this page. Where is it? List of unsolved problems in physics. It's actually really cool. Here is a list of unsolved problems in physics. I thought it was, I don't know, I think it's really neat. So I think the link I gave you automatically goes to general physics and quantum physics. We have the arrow of time, totally cool, something that we've mentioned before. Quantum physics interpretation. It's, I'll be honest, Zadiston, it is, if I were to point the camera at the ocean right now, it would be black. Like, here, let me just, okay. Right now, it looks like this. It's gonna take another hour and 30 minutes before the sun comes up. So, there isn't really much I can do about that. I just gotta let it kinda, I don't know, the sun kinda go up on its own. I can't coax it any, any faster. Well, if you guys want, I could just constantly keep the camera facing the window and you guys can just watch the sun come up today. Is that what you guys want? Totally fine by me. I don't have a preference. In fact, it might be easier if it was constantly pointing the screen, but the thing is, there's this screen in front of the window, right? And I kind of feel like, I don't know, the screen in front of the window kind of spoils the fun a little bit, I guess. And I can't really take the screen off. Yeah, no, probably not without breaking it. So, there isn't really much I can do there. But yeah, I thought it'd be super cool. We have all of these unsolved problems in physics, and I just kind of wanted to throw them at you. I mean, they're really cool. I can't touch any of these. I'll spend a few hours for intersecting spheres, and this was the result. Open link. Oh wow, that looks amazing. Wow, what did you let's see. So here's the light coming in. It refracts, sorry, out there. There's a little bit of reflection. Yeah, that looks really cool. Ah, man. I don't think ours is going to look nearly as cool as this one. But we'll see how it goes. I mean, yeah, it's fine. Oh, this is the Batman curve one. Oh, really? It looks a little different than mine. You should have the ocean in the back of you. I know, back for working at the monitor. Okay, so I know I haven't shown you guys my room, and I don't want to show you my room, but I can tell you that based on the size of my room, there is no way for me to do that. My room is literally like, my computer takes up, I'd say a good tenth of my room, right? And then my couch, I don't even have room for a bed. My couch is about twice the size of my computer desk. And that takes up another, fifth. Let's see, I could probably, yeah, there's no way. There's no way. I have, I'm sorry. That can't happen. Besides which, in terms of lighting, if there's light in the background coming in from behind me, then you're not going to be able to see my face anyway. So it's kind of just, I'd be this dark outline, and then there'd be light behind me, but you can tell what the light is. It's actually small in terms of Japanese rooms. However, the room I was actually assigned is rather large. The truth is, in order to do the stream every morning and not wake up my roommates, there's like this little closet on the side of the living room, and I kind of decided I would take that closet on the side of the living room for a number of different reasons. One, for some reason, it was the only room in the entire house that had an Ethernet connection. Don't know why. And the other reason being that I get up at 5 o'clock in the morning. The other room is closer to my roommates, and I don't want to accidentally wake them up. So I figured, I'm up in the morning. I'm talking to a microphone, sometimes quite loudly. And I didn't want there to be a situation where I was annoying the roommates. That said, I do kind of annoy the roommates a little bit because I go to bed kind of early. But so far, they seem to think it's okay. But seriously, Zadiston, this is a really cool image. I mean, you did a fantastic job with it. It looks really good. Okay. So, let's go ahead and keep working on our own visualization. We've got a whole bunch of things left to do. Pretty excited to see where we get. And I guess we'll just kind of do our simulations and see where we go. In terms of introductions, is there something we need to introduce? Not really. It's pretty obvious what it is that we're doing here. The list might not be totally updated. Let me see. Oh, the thing about pentaquarks, I heard that the pentaquarks were, like they were discovered, but it was like somehow not discovered at the same time. I don't know how to put this. Like it was like they discovered it, but no one was really sure if the discovery was sound or not. And so I think they're still trying to validate it. Let me see. Quantum gravity. I know nothing about quantum gravity. Extra dimensions. Oh man, the problem is, like as I'm going through this, it's Abraham Minkowski. I think I've heard of this one. Physics concerning electromagnetic momentum within a dielectric media. Related theories have been put forward, and should their principle be demonstrated true? Why have I heard of this one? Maybe it's just Minkowski. I've heard of him. Condensed matter. Bose-Einstein condensation. How do we rigorously prove the existence of Bose-Einstein condensation for general interacting systems? I don't know what it means for general interacting systems, but I work with Bose-Einstein condensates. So I feel like this is solved. Maybe not. Now the cool part is this one right here. I think it's so cool. Problem solved in recent decades. The existence of gravitational waves. Boom. Loophole-free test for Bell experiment. This one should be... Wait, is this not done by Alan S. Bay? One second. Calvi Institute, Quantum Non-Locality. I'm not sure. But I would bet Alan S. Bay had something to do with that one. Ball lightning. Ball lightning's so cool, guys. It's like lightning, but a ball. Higgs boson, Hipparcos anomaly. I don't know what this is, but it's really cool. I guess now would be a good time to mention that I have glass etching of a Calabi-Yau manifold that I got because I thought it looked pretty. One second, let me take a look at this. I don't actually know what that is. So Calabi Yau manifold. Oh, yep, I do know what this one is. In fact, this is one that I was just looking at the other day. Yep. Yeah, I do know what this one is. I don't know, I find... So at some point, guys, I wanted to do a mapping from 4D to 3D on this channel, so we can kind of get a grasp on what the fourth spatial dimension actually looks like and things like that. But I have not quite been able to figure out the paper that I was going off of. But it's certainly something I want to look into, 4D stuff. I just can't grasp my head or wrap my head around how it works, and it's something that I think a lot of people have trouble with, so it's definitely something I want to look into. But yeah, we'll see how it goes. Anyway, back to our simple geometrical optics, because we are so far away. I was in the fifth image. 1, 2, 3, 4, 5. Here we are. This is the one you got, I imagine, for crayons. Okay, so good. we have everything set. Pretty excited to see where we go. And what do we need to talk about in terms of introductions? I guess we'll do a quick introduction to geometrical optics, what it is that we're doing, and we'll go from there. Okay. So, in terms of geometrical optics, the one thing we really need to point out is that these simulations are not equal to wave optics. By that I mean, we are sufficiently in the regime where we do not have to deal with the quantum nature of light. Obviously, most people have heard by now that light is both a particle and a wave. There's the particle-wave duality. We're essentially imagining light here as a ray. It's a stream of photons in some direction. Now, what we're going to do looks exactly like the spider webs in my bathroom. What we're going to do is we're going to watch light as it moves through the system. So we will be moving our camera at the speed of light, but that's perfectly fine. You know, we're imagining it as a stream of particles, so that's okay. There's a couple things. Sorry for the yawn, guys. There's a couple things I want to point out here that I have not pointed out yet before. Let's say we have light. Oh my gosh, those are supposed to be straight lines. They weren't anything near straight. Okay, here's one straight line. Here's another straight line. Here's light coming into the system. Here's light refracting in the system. There we go. And this is going to be n equals 1, so it's air. And n equals 1.4, so it's like glass or something like that. Okay. The idea is that when light enters this medium, it actually is slower, according to ray optics. Actually, according to wave optics too, we showed that, didn't we? Then in here, it's faster. So there was one simulation we showed yesterday, and this is kind of why we did our simulation the way we did. Oh my gosh, femtosecond. Okay, we actually have some people here working on femtosecond stuff. It's bizarre what you have to do to get that to work out. Because obviously the camera itself, let's say, think about how many photons you're getting into your system in a femtosecond. In a nanosecond, it's a good bit of photons, right? But in a femtosecond, it is so small. The number of photons you get in the system is negligible almost. And in order to get a good image from femtosecond image, in order to get a good femtosecond image, you've got to be able to just, I don't know, you've got to play some tricks. And it's certainly not something that I fully understand, but I don't think it's beyond understanding. It's not like a lot of the cosmology questions where I know no matter how hard I look at it, I'm probably not going to be able to get it. So, I don't know. It's just something I wanted to point out. Nisimiko, are you a real samurai? I don't think I'm a samurai. Not that I'm aware of. No, I think I'm a fake samurai. Pretty sure. Okay, so faster, slower, that's the main thing I wanted to point out. There was a simulation we did yesterday, actually for the past few days, where we have... See that circle? That was a perfectly drawn circle. Where we have light going into the circle, and then it just kind of stops somewhere in the middle here. The reason it's stopping is because light is moving so slow that no matter how many more time steps we put into the system, it will never reach the center. He's the guy... Wait, who's the guy? He's the guy Tom Cruise played in The Last Samurai. Oh, are you guys talking about... Wait, what? Okay, so that's the system we have. And this is kind of why when we did our simulation, we did time-dependent ray tracing based on the velocity of the light. It kind of allows us to dynamically create a DT or a DX or something like that within the circle, so that we never run into resolution problems, because there will be times as we get closer and closer where we just run into some sort of DX resolution problem. But with the time-dependent ray tracing, it's a little bit more, I don't know, I don't know if it's more physical or not, but we'll see. Okay, so I think we're good to go. That's all the things I wanted to point out. I kind of rambled for a little bit, but that's okay. You know, we never had to say that this channel had to be on topic at all times. In fact, if we did say this channel had to be on topic at all times, we'd be in trouble. That might be why I couldn't get the invisible lens equation to work. Yeah, the invisible lens equation. The invisible lens equation is, as we zoom in, let me see, Mirage, I think I have the invisible lens, no, 1 second. I have to cd into the appropriate directory: projects, Simuleos, geometrical optics, then Mirage invisible lens. I don't think I can zoom in here, but actually, if we did, it's incredibly well resolved here in the center. Let me see if I can recreate it with what we have right now. So let's cd into projects, Simuleos, and what do I want? Honestly, I don't know. See, now the problem is this. The way Twitch Creative works, if I were to do that, I'd have to put a hashtag physics on my stream, and no hashtag programming or anything else, just hashtag physics. And if it's just going to be hashtag physics, if it's going to be hashtag physics, no one's going to watch it because of the way you have to browse Twitch Creative. So they're actually not going to know my stream is active. And that's kind of a pain. Anyway, so Project Simuleos and Geometrical Optics. LS, which again, I don't know if I told you guys this or not, but I have hashtag oceans I don't think works either. Covering the physics of oceans, that's a huge question. A lot of people do it. There was one simulation I did want to run, which was the, shoot, what is it called? There's a global warming model, climate change model. Let me see. It's the, climate change, global circulation model. This one was one that I wanted to look into, just because I thought it would be, general circulation model, my bad. Just because I thought it was interesting, you know, I wanted to see what's up with it. But, you know, it's a situation where I really do trust climate scientists. I don't, it's not like I have any debate there. So, I don't know, here's a link to that one. It's kind of interesting and kind of related. What else was I going to say? Oh, yeah, with the physics thing. I was actually thinking about creating a community on Twitch for just physics. You know, it's hashtag physics. But the problem is I have to create like a background image or something like that. And I can't really figure out what I'd do to make the background image appealing, you know. I was thinking about just getting a picture of a blackboard with a bunch of equations on it. I thought that'd be kind of cool. But that's me as someone who likes looking at blackboards with a whole bunch of equations on it. So I don't know if that's maybe the best thing to do. But I was thinking about just going ahead and a spherical cow. We could put a spherical cow, but that's kind of my logo, and I don't know the best way to put a spherical cow in there. That's not my logo, you know, because I can't obviously like put my own logo in something that's for a community of physics people. And that said, I'm the only one that's streaming physics on Twitch. There isn't anyone else that does it. So because of that, it's not a situation where there's really a community. It's really just me. A blackboard with equations of a spherical cow, that's literally just a blackboard with equations and circles in it. You know, it has absolutely nothing to do with a spherical cow. Well, rather, anything could do with a spherical cow. Maybe we could find something to do with, like, spherical cow. I don't know. I'd have to think about that one. Let me think. What else is there? Hey, Marion. What's up? Okay, so now what I want to do is go into... what happens if I just type in make plot? Does this still work? What happens if I type in make? Geometrical is up to date. What, make clean? Make. Oh man, I don't remember what I'm doing at this point. I remember we put things into a header file, I think yesterday or maybe the day before that. I don't remember. It is running geometrical. Let me do an ls over here. We should have nothing. Good, that's about what I expected. Okay, also speaking of fluid dynamics, I was doing more research into rheoscopic fluid simulation, and I found that most of the material out there deals with Cartesian coordinates, when cylindrical would be more suitable in my case. And there's also a matter of modeling shear flow. So, for the most part, when it comes to simulations of fluids, even superfluids, you're going to run into a resolution problem, right? And the question is where you want to run into this resolution problem. So new page before. At least this is my understanding of it. Favorite choice of intoxication, 2 days off due to holidays. Okay. So on the one hand, in Cartesian coordinates, that was supposed to be a square. Didn't turn into a square. There we go. Okay. We have a situation where we are along the x, y, or xz, or whatever plane you want to be on, right? And so your resolution is limited by these boxes. However, in circular coordinates, wait, oh, dang it. Circular or cylindrical coordinates, you have another situation where you're limited by these boxes here. And if you're limited by these boxes, it's kind of obvious that you have like more space out here than you have in here. And so it kind of just depends on where you want your limits to be there, in my opinion. Open link. Let me see what we got. David Lee. What is LI? Okay, let me see. Oh, that's pretty neat. Yeah, it definitely uses some sort of, well, I mean, particle model, obviously. Fluidity? Speed? Oh, I think I just froze it. Yeah, I just froze it. Increase fluidity, but drop speed. Edit. Particle density. Super dense. Start. Oh. Yeah, I think this is exactly what you want to do. It turns into more of an MD problem than anything else. Particle and cell is pretty cool. I think... I don't know. It's kind of fun to look into. But it's kind of hard for me to do anything like that for my research. So I don't know if I'll look into it or not. In the end, even though we're working on things that are... Oh, you can interact with the mouse. Let me see that. Open link. Start. Oh, you can. Whoa. That's pretty neat. What am I doing? So wait. So if we drop the speed, no. If we drop the fluidity, can we? No, I wanted to be Moses for a second. Oh. Almost. Okay, anyway, I don't know what I'm doing. I should be working on optics. Okay. Let's go ahead, close this. Definitely looks promising. Good luck with it. Okay. So, let's go. Geometrical optics. Let's see what we got here. So if I go into VI geometrical.cpp, let me just go ahead and show you the Newtonian optics. Yeah, it's geometrical optics. It's super basic optics. Let me go ahead and show you the invisible lens real quick. And let's do, how about 10 lights instead of 20? And then we're going to go down to the bottom. And let's see what we got. 1 second. So here we're here. And what I want to do is the following. Let's comment out some stuff here. Create background. Yep, I can probably... Yep, get rid of that guy. And everything else I think should be okay. Let's go here. And I have a separate makefile for the GNU plot stuff. So let me go ahead and CP the current makefile into makefile Cairo, which is what we're currently using for the visualization. And then we're going to CP makefile for the GNU plot over to makefile. Now we're going to make it, see if it makes. Radius was not declared in the scope. Oh. Layer was not declared in the scope. Oh. Let's do this then. 1 second, guys. DD. DD. Up to the top again. What else? Did I comment anything else out? I think that was it. Let me go to the top. Remove a couple things here. Let's leave it as it was. And instead, let's modify the current makefile. VI makefile. VI makefile. Cairo. Okay. And let's work on that. Mundo goes where he pleases. Dear God, buy some IDE. No thanks, man. I appreciate the offer, though. Okay. By the way, if you toss in alpha blending and end up the ray count, you'll probably end up with something like what I had, except more accurate. What do you mean by... Oh, alpha blending. Yeah. I know exactly what you mean. That's kind of what I was going to go for in a second. Okay. So what I want to do then is, let's see, we have all these bins, but I don't think the bins are necessary anymore because we are definitely using... yeah, we are definitely doing... how do I put this? Geometrical optics. So I don't have to worry so much about that one. So let's go ahead and remove that. And now let's go here, CXX flags. And let's just put in exactly what we have over here. So we have simulation objects, optic visualization. Yeah, I think this should work okay. Yeah. So let's just go ahead and remove these guys. Go here. Post this guy there. Actually, these guys here. And by that point, let's see. It sort of becomes numerical integration. So what's the reason you're not working in any IDE? I mean, there isn't really so much of a reason. I don't think there needs to be. The work I do, I'm always SSH'd onto some sort of local cluster. Opening up an IDE is bad practice. You know, using Vim is your best bet, or Emacs or something like that. A text editor is what people typically use. Now, some people will open up MATLAB or something on the cluster, but again, it's not the best practice because you're going to be either on a login node or you have to grab an entire node for just opening up your GUI or whatever. And that's kind of, I don't know, it's not the easiest thing in the world. Meanwhile, many things are quite lightweight. Vim is quite lightweight, so it's okay to do that without grabbing your own node, and it's perfectly fine. So it's kind of just a situation where, let's see, I think I changed this to sim. Yeah, so let me change this. But it's just a situation where it makes more sense for me not to use an IDE. Plus, IDEs don't really help me understand what's going on with the code at all. You know, it's really just there, so if you're used to it, you get it. But for me, I'm just not used to it, and it kind of doesn't help me any. So that's kind of it. So now what I want to do is change all of the sim for bins. So let's do that real quick. So :S, or whatever this is, S. We're going to do sim, bins, and then G. Good. I should probably go up here and remove these because they are no longer necessary, but that's okay. Let's go ahead and right quit. Let's see what happens if we make it. Missing separator, stop, make. Oh, sorry about that. VI makefile, what did I do wrong? Geometrical, plot, bins, GNU plot. What does a missing separator mean? Anybody good with makefiles? Krams, you said you were good at makefiles at some point, right? So let's go to line 9. Here. Oh, I know the problem then. Make. Fatal error, Cairo.h, no such file or directory. Let me see. Package, std, Cairo flags. Oh, I forgot to make it with Cairo flags. So let me go here. Plot bins, and then what do I want to do? When we make it, compile, here is what we want. Bins, we also want to add in Cairo flags. And now, CO, it should be okay. Let's see what happens if we do this. Make, okay, let's try it again. 1 second. What else did I do? CXX. Let me see. Oh, it adds it as a dependency. Okay, 1 second. I'm really bad with makefiles, guys. Let me see. So plot bins seems fine to me. Dependencies. You run it on the CXX lines. 1 second. Oh, you're right. Duh. My bad. That's exactly what we have over here. Okay. So we want CSX flags. Go here. And then we do Cairo flags. Right, quit. Now let's make it. That didn't work. No such file or directory. Did I misspell Cairo flags? No, it seems okay. Let me see. Start at CPP. Oh. I guess we should probably do... Oh, it's okay. Hey, wait, what was wrong with this one? Right, quit. Make. No such file or directory. Cairo.h. Okay. Make file. CSX flags. Cairo flags. Oh, bins. Okay, let's just try this. One second. Cairo flags might be blank. How is Cairo flags blank? Check what's running. Package config. C flags libs Cairo. Does it exist? I mean, it works over here when we run this make file, right? So I can't imagine. I can't imagine it's that big of a deal. But let's try it. Package config. C flags. Libs Cairo. Yeah, totally exists. We should be fine. Okay, so let's do make file. So then, let me see. Star.o. Oh, you know what I'm doing? I'm doing this all wrong. Okay, so let's see. We want plot. So we want /bins dev null. That seems fine. GNU plot. That's exactly what we want. But what we need to do also is add in this line here, so that we make all the dependencies. And then, why not? We will also add this line here. And let's see what happens. .cpp. I have 2 dots and a CPP where? Let me see. Should only be .cpp. Let's look for it. Oh, you're right. That does have 2 dots. One second. Let me just... Oh man, 1 second. Freaking tabs. One second. Let's see what happens if we right quit. Make geometrical is not up to date. Make clean. Make. Seems to be doing something. Make plot. Okay, it's definitely making the plot. The make file's a mess, but that's okay. Let's go into the make file one more time. I think there's some things that are unnecessary here. Probably these lines. Right, quit. Make clean. Kind of bumped in right now, so I'm not sure it's useful. But in order to not fight with makefile, there's a way to using generic makefiles for short products. I had someone generic makefile on GitHub. Yeah, that's fine. We're basically using a generic makefile. But thank you so much for the suggestion. Now let's do make plot. And good. Okay, so I think this one will do just fine. What we currently have. We had to kind of do a special makefile for a number of different reasons. But again, thanks for the suggestion. So let's go ahead and do control D is what I wanted. And let's go into the makefile one more time. And this is what I'm using, guys. I apologize if it is a little annoying, but hey, that's okay. So we are going to now take a look over here, right click, and let's change up our lens a little bit. So we're going to go down here, and let's, problem he's running into, he's using a generic, yeah, yep. Okay, so let's go here. Let me just change the index to 5, just so that we can make sure this is doing what we want. So let's go over here, make plot, give it a second to make the plot, and then we'll be good to go. That's not what I wanted. So what I just realized is the makefile does not remake it. 1 second, let's go into VI the makefile. Let me think. So make plot should always, how do I make plot also make it? Or should I just always do make and then make plot? Because then in that case, okay, let me do it this way. CP. I realize we just spent like 20 minutes working on that, but I apologize for this. Cairo, into the makefile, make clean, make new plot. Yep, that's about what I expected. Okay, so it's okay, we're set. At the end of every one of the running steps, every time we run the code, it also will go through and create the data file we need. So we just need to run new plot and we're set. I'm not going to worry so much about making and make plots anymore. Make it so that make plot depends on the output of make, and then move plot to the top. Make plot depends on the output of make. I actually don't know how to, fine, let's take a look at it one more time. Control D is what I want. Now let's go into VI makefile. Let's go over here to makefile Cairo, or GP. And we want plot here. So what do we want? We have everything else basically set like it was. Yeah, I just don't know how to make it dependent on that. You know what I mean? I don't know. Yeah, well, okay. I think that's probably the best bet, just to worry about it later. Okay. So we're running into a bit of a problem. And that problem is that with the refractive index, the way that we currently have it set, just make executes the first one. Yeah, I know that make executes the very first one, and that's fine. So let me go into geometrical.cpp one more time, and let's change the refractive index to something a little bit smaller. Let's say 1.4. We should see a focusing of light, and that should be exactly what we want to see. So let's go here to make one more time. Make clean. How do I make it to make clean every time? Then we run the last new plot command. No, that one didn't work. Right here, make. Control D, make. What? What just happened? Terminal's not doing anything. So let's open up a new terminal, because screw that terminal. One second. What the heck? What's happening? I'm getting a lot of freezes for some reason. You really don't want to make clean every time. I do want to make clean every time. CD projects, Simuleos, and geometrical optics. Make. Give it a second. Okay, so now what we want to do is the last new plot command. Okay, good. This is about what we expected. Now, the circle is not in the right spot, so let's go ahead and put the circle in the right spot so it makes a little bit more sense as to what we're doing. So, let's see, what do we need to do there? The circle will be in the... Oh, let's just go ahead and write this. Go up to the top and let's see where we're putting that circle. 1 second. The circle should be... let me go down to main. should be defined somewhere in here. So it looks like the circle is going to be... Wait, where is it? Sphere length, here it is. So it's going to be layer resolution x divided by 2, layer resolution y divided by 2. That's going to be its x location, and then its radius is going to be, where is its radius? Layer resolution y divided by 3. That's kind of a pain. So let's go here just for now, since we have a standard resolution, and let me go into the new plot. Let me see, it should be geometrical.gp. We are currently putting the object circle at 10.5, size 4. What we want is, see what we want. We want, 1 second. So it's going to be 300, I think, 300, followed by 450 divided by 2, so it's going to be 225. Size 4, so this is going to be 200. Now let's go ahead and run the last new plot command. And our circle's not quite in the right spot, is it? 1 second. The radius is actually going to be 100, maybe? New plot. Nope. 1 second. What on earth is the radius? The radius is resolution y divided by 3. Oh, it's 150. Geometrical 150 is what we want. I should have guessed that from what we saw. 150. We'll quit. New plot. There we go. Okay, it's in the right spot. We're good. We have light going into the circle, doing its thing, coming out of the circle, and focusing at a particular point. It's a little bit weird that we aren't seeing pure focusing here, but that's fine. That's something we can worry about later. Okay, so now let's go ahead and go back to the previous formula that we had before. Oopsie. D10D, DDDDD. That was my bad. I'm using compatibility mode. Let's go up here. Index of 1.4. Let's go back to the index we had before, just to make sure it works. Write this. Go over here. Control D. Make clean. Make. And then we do, 1 second, after it runs, the last GNU plot command. And here I think is the coolest of our simulations that we've done so far. It's the light just not entering the circle. Again, like I said before, the problem is light is slowing down as it's entering the circle, and it's slowing down more and more and more and more, and no matter what we do, no matter how far we allow the simulation to go, it will not hit the center, assuming we're appropriately resolved. And that's incredibly cool. Now let me see if the invisible lens works here. I'm not sure if it will or will not. So what I'm going to do is the following. I'm going to take this guy, and I'm going to comment out this entire if statement. Comment this guy back in, and we're going to see what happens. I've got a feeling it's going to be a little bit weird. So make... See, this is why, how do I get it to make clean every time? Or at least remake. I can't figure that one out. I have to make clean every time. Make clean. Make. Give it a second. Then we're going to run the last new plot command. Okay, so this one seems to work okay. The only problem is the guy in the center here, which completely stops. But again, that's okay. Let's increase the number of lines up to the top, change it to 20. Right, this, and I think at 20 we run into a problem. So let's do, let me see, make clean, make, give it a second to do its thing, and then we'll plot that one. 1 second, so new plot. Good, okay, so this one's okay too. The only problem is that one line that disappears at the start. So, what I wanted to point out here is if we zoom in here, and we zoom in again, we actually run into this weird situation. Hey, Screamer Chaotix. The paper mentions singularity at r equals 0. Yeah, so what we typically do at r equals 0 is we just allow the light to pass through. And that's why what we did before, let me go down here, is we had some sort of, 1 second, cutoff. So if I add this cutoff back in, put a 1 in here, then we run into a weird situation. So if we do make clean, make, and then we run new plot afterwards. I'm sorry about being so bad with make files, by the way, guys. New plot here. Then we run into a situation. Oh, wait, what? It should go through. Why doesn't it go through? 1 second. Maybe it needs to be higher. Index equals 100. Yeah. Let's go here, Control D. Make clean. Make. And give it a second. We then do new plot. Yeah, okay, so this is what we wanted to see. And this one actually looked pretty good. I mean, that's quite good. So if we zoom in on the structure, eventually we run into a point where it just continually repeats itself the farther we go in. It's actually incredibly cool. That said, man, I definitely want to... Anyway, that said, it's not exactly the, how do I put this? It's not exactly like a fractal or anything like that. It just kind of repeats itself on the way in. One thing to point out is this one line here goes a little bit further than all the other lines. That's again because we're running a time-dependent simulation. So what's super interesting about this simulation, or what I find super interesting, is that we have light coming in here. It's coming out here. All of the rays, and this is super cool, all of the rays are coming out at the same at the end, and they all have the exact same time delay. That's amazing when you think about it. They all have the exact same time delay except for this guy. This guy's off. Sorry about that, but everyone else is fine. The only reason that guy's off is because I'm not setting the radius or the cutoff appropriately. If I were setting the cutoff appropriately, I assume that everything would be set. And you can actually see the time delay here. This right here is a line without time delay. And this is one with. Maybe change the 100 to 1. Changing the 100 to 1, I think... Here, let me see. Change this to a 1. Would only allow the line to move a little bit further. So let's do make clean, make, give it a second to do its thing. Hey, clone style, what's up? So 1 second, give it a second to do its thing. And then we will new plot. It looks exactly the same. I think this line's a little bit further out, but I don't think it's that much further out. So I think it's okay. But yeah, so that's the invisible lens. It looks really good, in my opinion. I think it looks great. But for now, I'm gonna comment it back out because I kind of want to work on other things right now. So let's go ahead and, I mean, we could leave it in. It doesn't matter. Whatever, we'll leave it in. Doesn't matter that much. Okay, so now what we need to do, simulation's going well. We're just kind of, you know, taking it one step at a time. So now we have to do the plotting with something else other than new plot. Now that new plot's not nice, I mean, new plot is cool, but let's see if we can make this look super pretty. I figure the prettier it looks, the better. I mean, the more eyes it'll grab, and the more eyes it grabs, the more, I don't know, eyeball soup we can make or something. I don't really know how this works. Okay, so we have the background layer being created and everything else being formed just fine. What we want to do is go into propagate. And this time what we want to do is we want it to be that propagate, instead of reading output, reads in the layer that we want it to write to. So we currently have 3 layers. Oh, sorry about the yawn, guys. And let's have it read in. Let me see. Yeah, let's have it read in a frame animation. So where's propagate? Propagate should be up here somewhere. Propagate. Nope, that's not what I wanted. Where's the tag? There it is. Now we can do this in a number of ways. We can keep the old functionality. In fact, it's probably good to keep the old functionality and write a new overloaded function in some way. And that's okay. I don't know the best way to go about this. I mean, I think in the end we're not going to be using new plot for that much longer, so I think it's okay to go ahead and get rid of new plot for now, and then we'll kind of move with it from there. I think that's okay. Okay, so let's go here, and let's read in frame anim. And that should be okay. Good. So now we're going to go down to propagate. And let's see what we have. We have propagate there. Not what I want. Oh, actually, I did need to update that one too, didn't I? So let's change this to frame anim. 1 second. Frame ampersand anim. Let me go to the other propagate 2 here, and let's change this to layer 1. So there's 3 layers, we're just drawing it on the center layer. We can obviously manipulate this any way we want because we're kind of drawing it from scratch, but that's okay. So what we want to do now is we want to go through and animate all of the drawing of this guy. Now the thing is, we really only need to draw the line. We don't have to worry about anything else here because we could use the animate line function, but the lines are only probably going to take 1 frame to draw anyway, because we have so many time steps. So we can kind of play a game here. We could play a game where we have fewer time steps, but more, oh, how do I put this? But we have to animate the line. I think for now we're just going to draw the line. It's not a horribly big deal, and I don't mind having to do that. So when we do this output, we have to think about how we want to do this. So we do array p. Good. So instead of doing it this way, what we want to do is, oh, actually, you know what? Maybe we should use animate line. Animate line has some stuff in it that's pretty cool. So here we're going to do this, there, and there. We're going to leave it in just because we may need it at some point. And then we need to comment this out. Oops, that wasn't what I meant to do. Propagate next. Down to the bottom of the propagate function here, and let's comment this guy out. Good. So array previous index, I think that's the only time we use the output, so I think that should be okay. So now what we're going to say is this: if I mod 1000 equals 0, 2 equals 0, we then animate the line. So how are we going to do this? Well, we need basically 2 points. The point where it started and the point where it is ending, right? So what we should probably do is keep track of a, how do I put this? Keep track of a temporary point. That will be the original point that we started with, and then we move on to the next point, the point that it's currently on. So let's do it. We're going to go up here and define, what is it called? A position? Scope to 1, struct vec. Let me see. Vec has an XY, and it has, I guess it's vec. Good. So let's go down and let's see what we got there. So propagate. And we're going to say, we're going to say vec temp point. That's fine. And I think, yeah, so I think what we can do is the following. Temp p is equal to vec of, can I do this? I'm not sure how we defined it. Let's go here. And let me see what happens if we just make clean, make. It looks like it is running without too many problems. It's giving me some warnings, but that's okay. So, what are we doing next? Well, we have the temp position. So at the start of each of these loops in here, we have the time resolution. Oh, I guess we're tracking each individual ray, aren't we? Yeah, it looks like we are. Okay. So then we also need to keep track of the current frame that we're at. So let's go here and let's say int start frame equals animation. Yeah, animation.current frame. Good, I think that'll work okay. And let me comment something in real quick. Temporary position. Where the line starts every time step. How about swapping the nesting of the loops? 1 second. Auto raise. Yeah, I mean, I guess it doesn't really matter that much, right? In fact, I think if we just swap them, there isn't going to be that big of a problem no matter what. Let me think. In the end, it's not going to change, I don't think, anything. I think it's all going to be the same. Yeah, I'm pretty sure it's all going to be the same. But sure, we can. You're right. It might look a little bit better if we swap it. So let's go here. For auto ray and raise. 1 second. I added in some spaces. My apologies. Right, this, now, I think everything else should be good. So let's go down here. And let's say, ray.p, actually temp.p, equals ray.p. Good, so now we have our positions in X and Y. And what else do we need? Actually, I think I know what we need. Let me go into, let me ls here. And let me go into, what do I want? I want optics visualization.cpv. I have the feeling, let me see, animate line is what I want. We need frame, yeah, so we need positions is what we need. Now we can do this in a number of ways. We can modify it so instead of needing positions, we need vectors, which is perfectly fine. Or we could just, I mean, the vectors and positions are the same thing, right? So, let me see here. In fact, I think they're called the same way too. So let's go down here and let's just change these to vectors. Let's see, so vec there. And change this to a vector. I don't know if this is a run or not, but we'll see. So now we need to go to the, anywhere we have a position and we need to change it to a vector. So let's go to the following. Yeah, this should be fine. So let's do this. Position, vector, G. Good, so that should fix all of it. Will this break anything? Maybe, let's go up to the top. Now, where do we define position? Position. I guess it's now vector, isn't it? Oh, it's probably in vi optics visualization.h. And let's do the same thing. So we're going to change all of these guys. 1 second. Positions to vectors. G. Good. Because the way you render everything in one frame before moving on to the next one. Pervents? I don't know what pervents means. You place... Oh, you're right. No, I didn't. Wait, how? That doesn't make any sense. Oh, I see. Okay. CPP. Now let's go into optics visualization.h, and let's put in the vector from our file over here. Let's go over the top, and where's vector? Vector is here, and let's pop it over here. Now let's remove it over here, and let's run the code, see what happens. Worst that happens is it doesn't compile. We fix those errors, and then we go from there. So let's do make clean, Actually, can we just do make? That one worked that time. I don't know why. Okay. It looks like that one ran. So let's see what happens. Specificus, actually, we don't play games on this channel. I apologize for that. It's actually specifically a channel. For a while, it was focused exclusively on computational physics. Now it's just kind of focused on coding in general, but we still do mainly computational physics. And by computational physics, I mean physics that is done with programming. That's what we kind of focus on here. I realize, sure, yeah, it's kind of weird not to have so much gaming content, but you know, that's what Twitch Creative is for. That's kind of what they want, where they want to put all of the non-gaming related stuff. Now again, like Zadison mentioned a second ago, I probably replaced a position I didn't need to or something like that. It's fine. We'll see what happens as we go further along. Okay, so now we have to draw everything out. We have animate line, and let's see what it needs. So here's our output right here. And let's go from there. I do understand it, but do you play any? Oh, me personally, honestly, I don't play too many games. The games that I do play, or I have played recently, Guild Wars 2, I enjoy those games. I play them with Wine on Linux. I enjoy Don't Starve and Don't Starve Together. Those are some fun games. Let me think. In terms of other games, I can't think of so many. Hey, Edge226, what's up? I think I'm also doing fantastic. Thanks for asking. I can't think of any other games I really play that frequently. Let me think. No, I think Super Smash Brothers. If people will bring that game over, I will definitely play it. But again, most of the time I spend my time either programming or creating content for YouTube or something like that. I don't really have that much time because, you know, I'm also a PhD student. So don't really have that much time to do that much stuff. Okay, so I think, unless I'm completely incorrect here, I think we can just go ahead and animate the line. So let's go into VI, optics visualization.h, and let's see what happens. I ordered a bunch of hardware and I'm solving problems before I get the equipment. Oh, good. I'm glad you are working on things. So animate line. Here's what we need. So we're going to want frame anim. So let's do animate line. And what do we want? We want frame. No, we just want anim. Should be okay. Then we want start frame. So we want animation.current frame. No. We want start frame. Good. Then we want double time. And we're just going to put this is a 1. I don't know what that means. If that means 1 second, that means 1 second. That's going to be incredibly long. Let's say we have a resolution of 60 FPS. So let's go down here and let's change this to 1/60. We might need to change this to like a 0.0 over 60.0. I'm not sure. I'm very bad with doubles. Okay, so 60.0. Then we want the two origins. So this is going to be temp position is where we start. I think I just called it temp p. And then we have the current position, which is going to be ray.p. Then we want the color, which is going to be... 1 second. Is it me or is your webcam or audio out of sync? Could be. Could be out of sync, and there isn't really much I can do about that. How out of sync is it? Bobson, let me know. Because it's about time that I just switched the camera to point at the ocean anyway, so that's okay. This is really cool. I've always wondered how physics and programming works and how complicated it is. So the programming in physics isn't so bad. It's actually usually super easy physics. The programming, it's usually super easy programming. The physics is usually the hard part, usually. So now we have to give it a color, and I'm just going to say color white. I'm just going to call it white. I'm not going to worry about it. So let's go ahead and remove these lines here, add in a semicolon at the end so it's all in one line. And let's go ahead and define our color. So we go up to the top here to our propagate function. Here we are. And let's go ahead and define our color. So we're going to define white color for funsies. No, just for fun. So we're going to say color white. Let me see. It's going to have an RGB value. And I think we can do it like this. 0, 0, 0. Or is it 1, 1, 1? I never really know. And I apologize for that. I never really know. Okay. I know I've done this before though. So let me go here. Let me open up a previous code where I've done this before. So let me open up, I believe it's going to be in Huffman. Then how about Huffman visualization.cpp? Yep, that's what I want. Now let's go to color. It's fine. That's fine. Also fine. Where do I define my color? Line color, red, green, blue. Do I have a main function here? Yeah, I do. Okay, so layer, current frame, create background. We read in the color there. Perfectly fine. Color. Dag nabbit. Where do I define my color? Color, line, color. Color, encoding. Okay, that's what I want. Good. So let me go into geometrical.cpp. Let me look for color again. And let's change it to what it needs to be. Here, color white, and it should be this. Now, the question is it all zeros or all ones? And that, I don't know. I think it's all ones. I think it's all ones. But don't kill me if it's not all ones. Okay, so now what we're gonna do is change start frame at the end of this loop. Let me see, the time loop is here. Okay, so we want to change the time loop, which is the outer loop. So here we're going to say start frame is going to be equal to animation.current frame. Let's go here to, thanks Addison. Let's go here to write and quit. Go here to write, and let's run make and see what happens. Oh, I forgot to draw the frames. But it seems to run. That's good. That's everything I want in my life. So let's go down and check this out. So, 1 second, I'm thinking. This might take some time. Yeah, I'm definitely thinking. Yep. Oh, I know what I need to do. Draw layers. It's taking a while to run. Control C is what I want. Write this, go over here, and now let's make it one more time. This is pretty chill to watch, even though I have no idea what's happening. Well, I appreciate that. If you have any specific questions, let me know. All we're basically doing is we're taking a lens, a circular lens, and then we are modifying the refractive index as you go into the lens such that we have the light bending and moving around as it's going through. It's pretty cool. I think, at least when I saw it for the first time, I was absolutely wowed by it. Now what we're doing is trying to get this visualization working. We kind of want to draw all of these lines and watch the light as it's moving through the system. And we're gonna see what happens. You know, hopefully this works. We're drawing the images now, and we'll see what it looks like. Maybe it works automatically. Maybe we have everything just kind of working first shot. Probably not. Okay, so now let's go into Mirage frames, and we want image 0000.png, and let's see. Oh wow! Oh wow! Okay, it's doing something. Not exactly what I expected, but it is doing something. Okay, so let's see. What happens if we zoom in? I'm not really sure what's happening here. We are... Yeah, I just broke it. Yep. Yeah, it's broken. Yep. Okay, well that is something. So now what do I want to do? I want to try to fix it because it's currently broken. So let's do this. G. And let me see. So what if we want to, instead of animating the line, let's draw the line. Okay, so where are we? We are right here. Animate line, we have animation start frame. The time it takes to get from point A to point B, which we're assuming is 1/60. Temp position, next position, and then the color. Color was fine. Color looked good. So how about this? We say animation current frame. Start frame is going to be animation current frame. So let's do this. Animation current frame. Dot current frame. Plus plus. Let's go over here. And let's make it again. Make clean. Make it again. It takes a while to run, and I don't like that. But I guess there's not much we can do about it, right? So we'll see. Oh, that one didn't take any time at all to run. Huh. Okay. Well, we'll see what happens. Again, the resolution can be improved upon. That's just a matter of having a high resolution image to work with. And what do we have? Uh-huh. Look at that, guys. We're getting there. We have a whole bunch of dots on the left. Let me see. Might want to do something about the lines not being all dotty. Yeah, that's something that I need to figure out. I'm not sure why they're all dotty at all. I have no idea. Let me think. So we have animation current frame. We could just do a Cairo line 2. Hey, Gustorn, what's up? Okay, so let me try removing this line again and let me see what happens. Write this, go over here, control, oh, that's not what I want to do. Configuration has been modified. Overwrite, no, oh shoot, I just closed my terminal. Dang it, I'm sorry. Now I'm gonna have to do something, which is always annoying when I have to do it, but especially on stream. 1 second, move this over here, drop it down here, and good. Okay, pop it back over here. I apologize, happens sometimes. Okay, so let's go ahead and write this, go over here, cd into projects, simuleos, and geometrical, and let me make this guy one more time. Sorry, make clean, and make. Give it a second. This one will take a little bit longer to make, and I'm not sure why it takes so much longer, but it totally does. Thanks, Specificus. Okay, so let's give it a second to do its thing. More than a second. It's going to take about a minute. While it's running, how is everyone? I hope you guys are all fine. The world is good in your world. What? We're all on the same world. That didn't make any sense. Speaking of which, as I was recording my Huffman encoding video, I decided I wanted to make a Huffman forest of a whole bunch of inspirational quotes. And I did like a couple inspirational quotes to start with, and then I ran out of inspirational quotes. So then I just said, like, I've fallen and I can't get up, which isn't really inspirational. And then I made this whole story up, and it was really kind of rambly and not on point. Somehow I ended up being a dolphin. It was really weird. It's not going up on my channel. But it definitely happened. So let's look at the last image. Scroll down a little bit. Okay. So a couple of things we need to fix. It all appears at once. That's kind of a big problem. The other thing I want to fix, here, let me zoom in, is the dottiness. But I'm not sure if the dottiness is an issue with, let me see. Yeah, I'm not sure if it's an issue with the resolution or if it's just being drawn funny. No idea. But we're getting there. Also, because we're using Cairo here, after watching and reading several hours of strategy explanations. Well, Guster, I'm glad you know way more than I do about it. Yeah, so what I need to do is write a new function. I need to write a new function. Or we could just do Cairo line 2. Yeah, let's just do Cairo line 2. And we'll give it... The dots will look good in animation. I don't know. We can't get it animated, right? So let me think. So we're animating a line. We're giving it time. Let's see if we just give it a 1 here in time. So let's do the following. Let's say we have animation.fps already, right? So if we have animation.fps, then we simply need to multiply the frames per second by... we only want it to be 1 frame, right? What did I do before? I know there was a way to get it to just be the time of 1 frame. Okay, so it's animation FPS, frames per second, and I want it to be 1 frame. So it should just be 1 over animation frames per second gives a second per frame. So I guess it's 1 over FPS, which is going to be 1 over 60. But I guess this is more general in a way. Okay, let's just go ahead and get rid of spaces because I'm cheap. Let's go here, and let's try making this one. Let's see what happens there. This one will take some time too, I'm pretty sure. Now, I'm going to have to look into the animate line function while this is currently doing its thing. So let's go ahead and right quit VI, what do I want to do? What am I doing? Optics visualization.cpp, and let's go to the animate line function. Here it is. Scroll down a little bit. And let's see, if start frame plus draw frames is greater than animation current frames, animation current frame is equal to draw frames plus start frame. Okay, that's about right. So what does that mean? That means, why is start frame always the same? Because it looks to me like we are increasing animate, or the current frame every time. Put the arguments on different lines. Don't remove the spaces. Makes it almost unreadable. Okay, fine. 1 second. Let me see. This will probably have the same issue we had before. I was pretty sure it wasn't an FPS issue. I was pretty sure it was another issue, but that's okay. Scroll down a little bit. Yeah. So like frame 1, it's all of a sudden all drawn. So that's one of our problems. Hey, Duck of Doom 12, how are you? Right quit. Geometrical as CPP. Let's scroll down and let's see what we got here. I think I need to go to the propagate function. Yep, here we are. And now let's find what we need to do. Okay. So animate line. It should be increasing the what am I saying here? It should be increasing the current frame every time. So we have some sort of current frame that we're working off of. The time resolution up here, we're going from I equals 0 to I equals time resolution. And then here, start frame is equal to animation current frame. Okay, so we're outputting every 1,000 time steps. What happens if we just change this? What if we change this to 10? Does this solve any of our problems? I don't think so. I think this is still going to be broken. Yeah, this is totally still going to be broken. I don't even know why I'm trying this. Make clean. Make. Okay, but while this is going, let's see if we can figure out why it's all drawing at the same point. So we're doing animation, start frame, 1 over animation FPS, which should mean that we're increasing by 1 frame. Then we're going to the starting position and the ending position. Now, one thing we do know is that the starting and ending position thing is working correctly because in the end we are drawing the appropriate image. It's just all being drawn at once and we want to show an animation of the line kind of moving through, right? So let me think. Is there a way to make it time dependent? I think the time is the number of frames to animate over. I mean, I'm pretty sure it was an actual time. Right, quit. VI optics visualization.cpp. G, and let me see, what do I want? I want to go to animate line. Here. Let's see, time. Yeah, so we say the draw frames is time times frames per second, right? So this means that if we have the number of frames is going to be equal to time times frames per second. So it's definitely an actual time. I don't know why I decided to do that, but I did it that way. So I think that's okay. Time times frames per second. So this means we should do 1 frame, right? Because we're 1 over FPS, so it should totally be 1 frame. Yep. 1 frame. Okay, so then we go through. We have draw frames, and we say if start frame plus draw frames is greater than animation current frames, we then do animation current frames is equal to draw frames plus start frame. So we should be increasing by 1 every time we draw out a... Yeah, every time we draw out... Wait, 1 second. It's taking forever to run. It's probably going to take 100 times as long to run because I just gave it... Wait. Yeah, I'm not actually sure. So let me think. We have start frame, draw frames, animation current frames. That seems fine. It should be increasing by 1 frame every time we draw something. Okay, and then after drawing everything... Oh, wait a minute. Also, retrospect, maybe we shouldn't have swapped the loops. It's sort of broken right now due to the ordering. Wait, why is it broken right now due to the ordering? Geometrical CBP. Let's go to propagate. Oh, this one down here. Okay. Oh, yeah. You're totally right. Let's go here. Control C. That's what I want. Yeah. I need to bring this outside of this loop. No, shoot. Dang it. I'm thinking. If I mod 1,000. Oops, those were not zeros. That was not a zero either. 1 second. There we go. So if we are I mod 1,000, right? Then we animate the line going through with the current ray. Okay, with the start frame. So we all start at the same frame. And then after moving through... Oh, okay. Yeah, I get that now. Yeah, actually, let me try something. Let me try switching these again. Back to what they were before. So let's do this. Take this guy. There. Here. Right, this, go over here. And let me try make clean. Let me make sure it's written. And now let's do make. This one's going to take some time to run, I think, but I'm trying to think here. So we have our, I don't know, 20 lines, I think is what we have. I don't remember how many lines, but I think 20 was right. We're going through. I honestly thought this would take a lot shorter time to write out. So I now know why... I now know why we have all the dots. The dots make sense to me. It's because we're only outputting every 1,000 time steps. So we're drawing an incredibly small line. So I get the dots now. We have to find some way to fix that. So, yeah, let's go here. Make Mirage, that's what I want. Scroll down. Okay. So we can at least fix the dotting issue. Yeah, okay. But I don't know why they're all being drawn at the same time step. They're all being drawn on the very first frame. So the current frame that we're on is, let's say, 0. Okay. Then we say start frame is equal to animation current frame at the very end there, right? So we should be adding 1 frame every time. Yeah, we totally should be. Okay, so we got a couple things to fix. So let's go down here. Why don't we just do this? Start frame plus plus. There we go. D. You're not advancing the frames. They're all being drawn in the second frame. Well, but that's the thing. We are advancing the frame in animate line. Animate line should be advancing the current frame that we're on. Okay, so what we're going to say now is... Let me see. So we're all on the same ray. And then we go through all of the time in that one ray. So, let me think. Yeah, let's just do this then. We'll say temp p is going to be equal to ray.p. Okay, and we're going to remove this line here. Okay, now what we want to do is, in this loop here, set start frame equals 0. Let's go here, and let's do make clean, and make again. I think this should... Oh, I misspelled start frame. Now let's do make that. Give it a second to do its thing, but I think this should fix some issues. Yeah, I think this should fix at least the dotting issue. Maybe not the drawing on time issue, but definitely the drawing issue. Okay, took a little bit shorter time to run. I don't know if that's good or bad. And let's see what happens. And now we're gonna do Mirage Frames, image, PNG. Okay, well, we got somewhere. Look at that, guys. Look at that. Holy cow, that looks cool. Wait, let me do this then. We're gonna set this to not 1,000. Let's set it to 10,000. Now let's do make clean, and then make. Okay, 1 second. And then we need to fix the only other issue, which is that dotted issue. That's something that we need to figure out. But I'm liking this so far. It's turning out okay. Man, that looked cool. Ah, gosh. Oh, did I miss something? Wait, let me see. Oh, that's the Mahjong thing. Okay, so let's go here to Mirage. See what happens. Scrolling down. Yeah, look at that. They're all dotted. Oops. It kind of still looks cool, but it's, Yeah, okay, so now we have to actually get the line to draw. Okay. So, why is it only drawing a dot? That's a super good question. So we're saying temp p is equal to ray dot position, the position that it was last time, right? So that means if it's at the position it was last time, it should be at, let's say, the very start. So at the 0 at the start. Okay. Oh, duh. You're totally right. Temp p equals ray p. So let's go here. And what are we going to say? We're going to say the following. So, if I equals... Okay. So here's what I want. And I not equal to 0. And then let's say if I equals 0, I equals 0. Then we set temp p. Temp p is going to be equal to ray dot p. Let's go here, make clean, and make. Give it a second to do its thing. And hopefully this one will look a little bit cleaner. And we'll see how it goes. Okay, we're drawing all the images. Now this is taking a lot longer to run than I would like. We could parallelize it if we wanted to. That's something we can look into, but I'm not interested in real time at this point. So it's okay. Okay, so we're drawing our lines. There we go, look at that. And we are at line 53, so we have a lot of time to go. Okay, the only thing I'm not liking here, if we zoom in, we have these dots here. I'm not exactly sure how to fix that. Alright, but we're getting there. Dr. June, why are we creating images and not editing the current image in real time? I think else would suffice. Oh, you're right. An else would suffice. Yeah. Oh, no, no, no. It's fine. I think it'd have to be like an else if. Why are we creating images and not the current image in real time? I don't know what you mean, Duck of Doom 12. I apologize for that. How would we edit the image in real time? Yeah, I'm not sure. I have no idea how to do that. Sorry. Yeah, I don't know. Okay, so let me do this. I can change this to an else if. I think it's an else if in C++. So else if I equals 0. Then we do the following. Temp p equals this guy. And let's do this. And change this to, how about 2000? Let's go here to make clean. And then make. Overlapping or creating a context. Overlapping or creating context. Why are we creating images and not adding the current image in real time? Putting the else after the I equals 0 and removing the I not equal to 0. Let me see. You can easily draw the screen with Cairo. It'd be much faster. I can draw to... What? I don't understand. Can we draw to a screen? Let me see. Image 258. Good. I don't know what you mean by drawing to a screen. Has a point. You can easily draw to a screen with Cairo. I don't know. GTK uses Cairo to draw to a screen, so you probably can. But I guess it's fine. I don't see the point really, if that makes sense. Like it doesn't really make sense for me to do so at this point. Like, I mean, I guess I can look into it, but I don't know. It seems kind of weird, doesn't it? Like, am I the only one that thinks it's weird? I mean, we're running a simulation, right? So you run the simulation, you look at the output. Yeah, I'm not sure. I can look into it, I guess. Okay. So now what I want to do, ls, and let me see. We have backup.dat. Let me go into the makefile, and let's geometrical. That's fine. But now I want to do, don't write images to this, write them to a RAM disk. I don't know how to do any of that. That's not something I can do. Okay, so what I want to do then is I want to run geometrical, and then I want to what am I looking at? So if I'm looking at the output, what is the output that I'm looking at? That's what I don't understand. I think what I'm doing right now is looking at the output, right? Is that not what I'm doing? I mean, I don't know. I guess I'm just not understanding. What we had been doing was looking at the output, right? We were outputting it to... But, see, I get that. Duck of Doom, I totally get that. And I hear what you guys are saying. I totally do. However, the thing is, I'm missing an object file from... What? You're missing an object file from the object variable? I just don't see... I don't know how to render to a screen. I don't see... It seems like it's a whole bunch of unnecessary effort, right? Because I'd have to figure out how to do all the GUI nonsense, and that's all a big pain. Up till now, I don't think I mean, that's going to take like 4 days to do. Like just getting a GUI up and running. And meanwhile, this is working right now, you know? And it's working well right now. Besides, we want GIFs in the end, and so it does a pretty good job of what we need. But I can look into it, but I can't do it today because I have absolutely no idea how to do anything with a GUI. It's completely foreign to me. Okay, so what you're saying is you want me to add in geometrical. .o. Make. Use some of your RAM as hard drive. If you want to tell the files. Dude, Duck of Doom, I don't know how to... Opening up an image is not something like... I don't know how to do that. I mean, I don't know how to like dynamically open up... You see what I'm saying? So like, I don't know how to go from this /geometrical to opening up a screen with like an X button on it. You know what I mean? Like it seems... No, I totally get it, guys. Like, I see what you're saying. It's fine, but I, at this point, don't think it's necessary. I don't know. Anyway, so let me go here. Let me... ls. Here's what I do. I want to go into one of the other files I have, Huffman makefile. And let me add this convert here. And then let me go into the makefile there. And put it here. dd. Right and quit. Now let's make clean. Make. Give it a second to do its thing. And then we can look into doing the GUI stuff. Again, it's not something I have any familiarity with. I have no idea how to do it. At all. None whatsoever. So give it a second to do its thing, drawing all the images, and then we'll go from there. Okay, so give it a second to make that. Could put it in temp. 1 second. I mean, again, it's fine. 1 second. It's concatenating all the images. And now let's go ahead and look at Raj frames animation.gif. Okay, and I think 1 second. Okay, so that was kind of jaggedy at the start there. And it's taking forever. We could probably make this move a lot faster. Yeah, definitely could. So let me take a look at the images. Yeah, okay. But I mean, it looks pretty good. We're getting there. Okay. So let me think. You write images to temp, usually randiff. Again, I just don't know anything about it, Duck of Doom. It's not something... I do have an SSD. That's currently what we're doing, using. If temp is a randiff, the image generation. I didn't know that. Interesting. No idea. So I guess just mount. What is it? Mount. When you run P? I don't actually remember. I gotta be honest, I don't know very much about this kind of stuff, so. Okay, so now I have to figure out, let's see if we can just do real-time images, Cairo. Let me see, Cairo in pictures, real life, vibrant city, Cairo OpenGL, real-time images, misspelled images. Okay, using Cairo with OpenGL. Yeah, so it seems not the easiest thing. So what do I need to do? I guess we do mount grep 1 second temp. It looks like temp type TMPFS. Yeah, 1 second. So it says temp is temporary file system. Okay, let me see. It's okay, Duck of Doom, don't worry about it. Yeah, sorry, this chat doesn't do emotes, but it's fine. You can do emotes like on the other chat. Perfectly fine. The Twitch chat that everyone sees online. Let me see. I'm not sure how to tell if it's a RAM disk or not. Sorry. No dev, real-time size. Okay, I'll trust you. I'm not sure how to know if it's a RAM disk or not. It says it's type temp file system. So, okay. So here's what I'm going to do. I'm going to go ahead and clear this terminal. Okay. So now, in order to... That's okay, Duck of Doom. So in order to get the images to appear in real time, we're going to have to create like... it being temp FS means it's a RAM disk, I believe. Okay, thanks, Gramps and Edge. Okay. So this is currently how we're doing this, and it's not exactly... Okay, so let me go into Mirage, image, or frames, image 0000, whatever, .png. Let me move down to all these images. It doesn't matter. Any of these images. Okay. So let's just stop here for a second. It doesn't matter where we stop. They're all the same. What we've done at this point is we have drawn a whole bunch of images, and we've concatenated them all into one image, right? So what we're doing here is we are running with... How do I put this? We are running the draw frames command, right? And so the draw frames command, basically it is, we have 3 frames. We have the background frame, an intermediate frame, and a frame out top. And each of these frames has a certain number of images in it. So it has 300 images in each of those frames. Or how do I put this? There are 300 frames in every layer. There are 3 layers. Does that make sense? Sorry, I was kind of mixing the terminology. 3 layers, background layer, intermediate layer, top layer. Then we have 300 frames in each of those. So that means what we're doing here with the current way that we're doing it is every 2,000 time steps, we are writing out one of these guys. So we write out one of these guys to one of the frames, right? And then we go through the next ray, and the next ray, and the next ray, and the next ray. And we keep doing it that way. Okay. So in order to do that in real time, I mean, I see what you're saying. We write to screen instead of writing to images. But I don't know how to do that at all. I have no idea. So I guess, can we do Cairo? Drawing to screen. Let me see. Using Cairo with X11. Select output screen. Let me see. Maybe there is a way to do this. I was thinking we'd have to create a GTK thing. Opening window. X11 is probably the most flexible graphical interface to make, which makes it a little bit complicated, at least at first sight. To open a window, you need to do the following steps. X open display. Select the output screen, default screen 3. Hey Frank. Yeah, X11, right? After the window is ready, it's mapped to the Cairo XLib surface. Okay. Baratod, are you in Japan? Yeah, I currently live in Okinawa, Japan. I'm going to grad school at the Okinawa Institute of Science and Technology. Speaking of which, Krams, I told you I'd do it. So here is the ocean. I'm just going to point it that way. Then you guys, there you go. For the last 15 minutes, I will have it pointing at the ocean. And there you go. Everyone happy? Good. It's finally light enough outside that we can do that. Okay, pop back over here. So, X11 is low level, James. That's why I use it. And why don't you pick QT? Because I tried QT once and it was a big pain in the butt. But that's okay. So, yeah, I think it is pretty cool. The Okinawa Institute of Science and Technology that I'm at, though it is in Japan, is fully English speaking. It's pretty cool. Okay, so now what do I want to do? What I want to do right now is create a better GIF image. The current graphics interchange format file that we have is kind of slow. So if I run, let's see, Mirage, I guess frames animation.gif, it crawls along, you know? You're learning QT binding for Python. Yeah, it's one of those situations where, again, I wish I knew more than I do about a whole bunch of this kind of stuff, but I don't. So we're going to get to a certain point at the end of this episode. And then we'll kind of go from there. Okay, so we need to move this a little bit faster. Let's go into the Makefile real quick. And let's create a new image here. Let's go here. Let's see what happens if we change this delay. I don't really know what will happen, but let's just say delay 0. And let's see what happens. I don't know. In terms of my ability to use Qt, again, I've done very simple things with it, but it's been forever. So I have to look into how to do it again. For the most part, all of the GUIs I've made lately are terminal GUIs. So I guess that says a lot about kind of stuff I'm interested in. So what we might do tomorrow then, guys, is we might take a look at that X11 stuff that Duck of Doom suggested, and we might try to make it so we can get these guys to immediately draw to screen instead of drawing elsewhere. 1 second, give it a second to... It seems jagged and slow. There won't be a tsunami on camera or anything like that. Why is it so slow? Let me see. How do we convert? How long does it go? I think I started with Qt5. No, Qt4, and then now I'm at Qt5. It was right at the transition between Qt4 and Qt5, and I had to choose. Okay, convert Linux. Let me see, images to GIF. Graphics interchange format, animation, PNG. Okay, this should work okay. Convert, but what I want, delay 10? What happens if we increase delay to 10? Let's see, so let's do this, increase it to 10. Oh, oops, what was I doing? Enter. Let me see. There's no way to make Qt graphs with GPL. I feel like I'm missing some part of the conversation there. Qt graphs with GPL. GNU public license, right? Yeah, I think I'm missing something, but that's okay. So again, what we'll try to do next time, guys, I'm going to have to look into it tonight. We have a whole bunch left to do in terms of the animating and stuff like that. But what I might try to do is make it so instead of drawing the images out, we just draw immediately to screen. But in the end, we're going to want the images. Let me see how fast this guy is. I'm not sure if we have to go up or down with convert. So I'm not sure. See, it still seems slow to me. Does it not seem slow to anyone else? It seems incredibly slow to me. Scroll down. See, I want it to be like that. Like, that's how fast I want it to be. Zoom, zoom. But this is me just scrolling through the images, right? So there has to be a better way to do this. Okay, let's go here. Let me think. So we have all these images being created. I guess we'll just try delay 1. Again, I'm not sure exactly how this command works. I should probably have looked that up before. I don't know what the loop 0 does either. I guess we'll look that up. And we'll see what that one does. Higher frames per second. What I want to do... I basically just want the GIF to move faster, right? So if I want it to move faster, what do I need to do to make it move faster? That's the question. Loop 0. What does the loop 0 do? 1 second. So let's take a look at this guy. So 1 would be a super low frame per second, right? But I still just want to concatenate all the frames. Whoa, what happened there? It just kind of... Oh, that's not bad. Oh, it's pretty fast compared to the other ones. There seems a delay. Let me see. What if we change this to 0.5? Would that help? Can we do that? 0.5? Is this allowed? I don't know. We'll see. Pressed enter and then it froze. Oh no, it's doing its thing. We're good. Okay. Give it a second to run, and then we'll go from there. But guys, again, we have a lot left that we can do here. And I figure we might as well learn as much as we can. Duck of Doom, I apologize for, before I did not mean to be, like, I wasn't shooting down the idea. Again, it was just something I don't understand how to do it, so I have to kind of think about it a good bit. It's not something that really comes naturally to me. Okay. Display the next image after pausing. So if we don't have a delay, it shouldn't do that, right? Set that to a terribly small value. Okay, let's set it to as low as we can. I tried setting it to 0 and that didn't seem to do anything. Oops. Colon W keys just appearing out of nowhere. Okay, give it a second. Yeah, but for some reason I thought it had to be an integer. I thought it was frames, not time. But if it's time, then we should be okay. Don't worry, it's just advice. I need to follow it and destroy what you have now. Since working with what I recommend is quite different than your current method. Yeah, it's something I have to think about, but you're right. It is probably better not to draw images out every time step. If there's a way to draw it immediately to screen, that's something we can look into. So let's do Mirage here. Give it a second, and I'm hoping this is going to be quite quick. Well, it looks slower than the last one. Yeah, it's definitely slower than the last one. Yep, that wasn't exactly what I wanted. Well. Huh. Okay, let's see if we can... Let's see, convert... No, it's fine. Don't worry about it. FPS. Let's see if we can do this. Nope, that's not what I want. Linux. Change frame rate of video without... easily convert your video's frame rate of video without re-encoding. AV encode, MPVox. Where is just... Convert Linux. GIF FPS. Convert delay and FPS in animated GIF. Okay. See what we got here. Convert delay N. Let's see. 100 over N is FPS. And it gets it at a rate of 12.5. Okay. So we want FPS of 60. Oh yeah, Edge is actually doing some really cool stuff. So let me see. So that's gonna be 12.5 frames per second, but I want 60 frames per second. So we want ticks are 1 out of 100 seconds. So let me see. 8 over 100 seconds between frames. Let me see. So I guess we try 1 point. Yeah, I don't quite get it. Let's change this to, let me see. Let's read this. As I understand it, the ticks are 1 out of 100 seconds. So 100 ticks per second. So a delay of 8 would be 8 over 100 of a second between frames. This makes the frames per second 1 over delay in seconds. Equals 100 over delay in ticks. So for IM delay of 8, you get 12.5. Okay, so how about we just remove delay entirely? We just remove this. See what happens there. I don't know what the loop 0 does. No idea. So maybe we remove that too. And we just see what happens. I don't know, maybe on Build Linux OS. It can be anything. Delay of 2 would be 50 FPS, right? Let's give it a second to run, and then we'll go from there. The problem is it's just not fast. It's not what I expected. So let me do Mirage animation.gif. Actually, wait, it's supposed to be 3 seconds in length, isn't it? 1 Mississippi, no, that's more than 3 seconds. Yep, that's way more than 3 seconds. Okay, let's try delay 2. And then we'll see what happens. Delay 2. I don't know what loop 0 does, but that's okay. Good. Sorry about that, I hit the mic. You guys probably didn't hear it, but that's okay. Man, I just wish I knew what was happening. Okay. But for the most part, we do have the animation being drawn. That's pretty good. Now it's just a matter of getting it to draw out at the speed that we want to draw it out to, which isn't so bad, right? We should be able to figure that guy out. Mirage frames animation.gif. Okay, so let's see. That's okay. Okay. So the coolest part about this, guys, is this is actually light going through our invisible lens. We have a whole bunch of stuff we have to do with this from here on out. We have to put a circle in here so people know where the lens is and a whole bunch of other things. But ultimately it's getting there. You know, it's totally getting there. I think it's pretty cool. You can actually see the time delay here as light's moving through the lens, which is exactly what you want to see. Even though the line coming into the lens is the same as the lines coming out of the lens, we still see that time delay. We definitely do, because there's light at its normal speed, and here's light at the other speeds. Now, there's some other things I have to look into here. You know, so let's zoom down a little bit. Let me scroll in. Control scroll. Am I not allowed to zoom in? Oh shoot! I think I just froze Mirage, didn't I? Yep, probably did. Yeah, it's frozen. Yep, that's frozen. Yep, end process. Okay, let's try it again. Scroll down a little bit. Probably should have started on an image, not the animation. Okay, scroll down a little bit. We're on frame 48. Zoom in. So the one thing I do want to fix, but probably not today, we have a whole bunch of dots in here, and I don't know how to fix those dots. It's kind of annoying, but it's not the worst thing in the world. So tomorrow I'll probably put the this GIF image next to my face down there, and we'll kind of go from there. At this point, guys, though, it's about 7 o'clock in the morning. We've made significant progress. I'm quite happy with how far we got. Sorry about earlier today. I kind of got frazzled when you guys were saying, like, don't write images. It's one of those things that I just don't know how to do. But that said, I should probably learn how to do it. So I might take some time learning how to do that. Let me see. Edge 226. I'm going to start building an ARM-based OS first, which will be super easy. Switch desktop from there. Linux from Scratchbook. Yeah, keep it all raw when you download source and go. Okay. Ugh, sorry for the yawn, guys. Okay, it's 7 o'clock in the morning my time. This is about the time I typically end the stream. We've got a lot left to do. I totally understand that. We've got to draw the frame, or we've got to draw the lens. We have to do a whole bunch of different visualizations that we haven't done yet. And of course, you guys mentioned that you would like to see it done in more real time without drawing the images out first. That's something I can look at too. Lots of things to do, and all of which I think will help our understanding of the system, or at least our ability to code up different things. Thanks guys so much for your suggestions. As always, it's super appreciated. Even if it didn't sound like it was, it totally is. I just sometimes don't know how to do things, and then I get kind of scared when people ask me to do things on stream I don't know how to do. Anyway, that's about it. Thanks guys so much for watching. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos, where we continue working on this, hopefully getting it to look even better than it currently does. We've got a lot left to do there, so my hope is that we can make it look absolutely, glorious. I don't know what that means, but, we'll see how it goes. Anyway, guys, thanks again for watching, and I will see you next time. Bye, guys. Oh, actually, Frank, I'm swimming tonight. Okay, stop streaming. Bye, guys.